So in this unit, we will look a lot at equations and different ways to solve them. So let's look at some basic exponential equations. First off, let's start with a warm-up so that we can develop a rule. Is f 1 to 1 when f is an exponential function? Well, there are two possibilities for f. It will either look like this, or it will look like this. In either way, whichever graph we have, it will pass the horizontal line test. So since it passes the horizontal line test, so it's 1 to 1. Now since it is 1 to 1, remember the definition of 1 to 1. If two outputs are the same, then it means that the only way that happened is if the inputs were the same. So let's look at that statement in relation to our exponential function. So what we're saying is f of x1 equals f of x2 guarantees x1 equals x2. So according to our function f, this is a to the x. So f of x1 would be a to the x1. F of x2 would be a to the x2. That, if we have those two exponentials equal, then that means that x1 is equal to x2. If two exponentials are equal, it's because the exponents were the same. Let's look at that rule. It's called the OnetoOne property of exponential functions. If a to the u equals a to the v, then that's true as long as u equals v. Let's apply that property. So 3 raised to the x plus 2 equals 27. We can rewrite 27 easily as a power of 3. 27 is 3 cubed. So 3 to the x plus 2 is the same thing as 3 cubed. Now we have two exponentials that are the same, and they have the same base, so the exponents must be equal. So x plus 2 must equal 3. So x must equal 1. We can substitute that back in to verify. 3 raised to the 1 plus 2 would be 3 to the third, which is 27. So let's take a look at this equation. We have 10 to the 3x equals 1/100th. On the right-hand side, we can go ahead and rewrite 100 as a power of 10. That's 10 squared. But now we don't have two exponentials equal to one another yet. But we do have another property that we can apply on the right-hand side. We know that a to the negative n equals 1 over a to the n. We're just going to apply that property in reverse. So 1 over 10 squared would be 10 to the negative second. Now we have two exponentials of the same base that are equal. That means that their exponents must also be equal. So 3x equals negative 2. Divide both sides by 3, and this yields for us negative 2/3. Again, we can check that. Substituting negative 2/3 in for x, we'd have 3 times negative 2/3. That'll be negative 2. 10 to the negative second equals 1/100th. That's correct. So now let's look at this equation. 25 to the x equals 5 raised to the x squared minus 8. Now, can we get the same base on these exponentials? Well, 25 is 5 squared. So we have 5 squared, but 25 was raised to the x. So 5 squared should be raised also to the x. And this will equal 5 raised to the x squared minus 8. Now, we have a property on the left that we can use. We have 5 raised to the second, and then that's all raised to the x. We can take these two exponents and multiply them. So this becomes 5 raised to the 2x. That is equal to 5 raised to the x squared minus 8. So 2x must equal x squared minus 8. This is a quadratic equation, so we can subtract 2x from both sides. We get 0 equals x squared minus 2x minus 8. We can solve that by factoring or quadratic formula, but it does factor. So x minus 4, x plus 2. And so x minus 4 equals 0, or x plus 2 equals 0, means that x would equal 4, or x equals negative 2. And if we substitute either of those back in, we get our answer. They do check. X equals negative 2 or 4. So here we have 8 raised to the 3x, and we have 16 raised to the x plus 1. Now these are both able to be written as base 2. So 8 is 2 cubed, and so that will be raised to the 3x. And 16 is 2 to the 4th. So 2 to the 4th will be raised to the x plus 1. And again, we will multiply exponents. So we have 2 raised to the 9x. And on the right, we have to be careful. We will have to distribute the 4. So we have 2 raised to the 4x plus 4. And now we can equate the exponents. So we have 9x equals 4x plus 4. Get the x's on one side. We have 5x equals 4. And so x equals 4/5. How can you be sure? Substitute x as 4/5 back into the original equation. You can use your calculator and check to make sure that the left-hand side would equal the right-hand side.